Hello and welcome to this first video in our lecture on hash-based cryptographic primitives. In the previous lecture, we discussed the general properties of good cryptographic hash functions. In this video, we're going to discuss a couple actual hash functions. We'll give a brief overview of MD5. We'll spend most of our time on SHA-2, and we might briefly discuss the other ones. Now, remember that the fifth property of a cryptographic hash function we discussed in the last lecture is that it be collision resistant. That means that it should be very hard, computationally speaking, to find two collisions, that is, two different inputs that give the same output. So one way to enforce this property is to make sure that the design of the hash algorithm exhibit this avalanche effect that we discussed in the previous assignment. And in particular, what that means is that if a small change is made to the input to the hash function, then there should be a big change in the output. So we'll see a demo of that on the next slide. Now, the application of cryptographic hash functions we discussed so far was the digital signature, whereby we hash a file to be authenticated or signed, and then we encrypt this hash code with the private key of the signer. And this is a way to authenticate the sender of a file or the owner of a file or the signer of a contract. Now, other applications of cryptographic hash functions are for intrusion detection mechanisms, and one we're going to discuss later on in the course is to manage password files. So for now, let's take a quick look at the MD5 cryptographic hash function. MD5 stands for Message Digest version 5. It was proposed by Ron Rivers in 1991. Rivers is the same R that we saw in RC4 and RSA. Now, this hash function has an output of 128 bits. So remember that the security of a hash function is not 2 to the n, where n is the number of bits in the output, but 2 to the n over 2. So this means that this cryptographic hash function has a security of only, quote unquote, 2 to the 64 bits, or 2 to the 64. This means it's somewhat vulnerable to a birthday attack. But actually, what's more worrisome is that over the decades, many vulnerabilities have been discovered for MD5, and people have been able to find collisions in MD5 for quite a while now. So what you need to remember is the reason I'm discussing MD5 here is not because it is a secure or a strong cryptographic hash function. Rather, I discuss it because, first of all, it was very popular and one of the early ones. And second, because it's available pretty much everywhere still. So I'm going to do a quick demo of MD5 here from my operating system shell, because MD5 is available by default. It's built into Linux and Mac OS. So at the command line, you can just type MD5, which will invoke this hashing algorithm. And the standard way to use it is to provide a file name here. And that is the content. The content of the file is what MD5 is going to hash. Now, instead of loading up a file, which I haven't prepared, I'm actually do something different here. I'm going to use the pipe symbol in the shell. And the pipe symbol, remember, is able to take the output of a command here and then forward it as input to the next command. So all I have to do here is to find a command that will output the string that I want to hash. And one such command is the echo command that takes a string and simply outputs that string to the standard output stream. So this echo command is going to send hello there to the standard output stream, and then the pipe symbol is going to grab that string and feed it as input to the MD5 command. So when I hit return, we should see the output of MD5 on the hello there string. And here is the message digest that you get. So make sure that you count the number of X digits in this message digest, and the number you get, multiply it by 4, since every X digit corresponds to 4 bits, and you should get a total of 128 bits. Now, to demonstrate the avalanche effect, I'm going to repeat this command, and I'm going to make a copy of it, and I'm going to run it twice. So I'm going to separate the two copies with a semicolon, which is how you sequence commands on the command line. Paste this command again, and I'm going to make a small change in the input string. I'm going to turn the lowercase h to an uppercase h. So I'm going to hit return. This will run MD5 on this string, and then it will run MD5 again on a slightly different string. And the output you get is, obviously on the first line, we get the same message digest as above, but notice on the second line, the message digest looks significantly different from the first one, even though the input only changes from a lowercase to an uppercase h, and all the other letters are the same. So this is a demonstration of the avalanche effect in MD5. For example, if you look at the first X digit, which is a 2, or in binary 0010, this becomes a C, which in binary is 1100. And so this means that for this X digit, 3 of the 4 bits were flipped. Now, in some cases, for example, here, none of the bits were flipped, 0 stays 0. But on average, a good cryptographic hash function should flip approximately half the bits just by flipping one or a small number of bits in the inputs. And so MD5 seems to be possessing this property of the avalanche effect. Now remember, MD5 is still not a secure hash function for other reasons, like it's not collision resistant. But you can see at least that MD5, the reason why MD5 was so popular until it was found vulnerable is that it does output a good length, at least at the time, hash code that was used for hashing in cryptographic applications.